A box can unfold. Watch it open flat. Count every face.
Watch the scene first. The math is built into the world, so the quantities can be seen before they are named. Today, we are going to represent three-dimensional figures using flat outlines called nets, and use those nets to find surface area. Look at this diagram of a rectangular prism with dimensions 3 by 2 by 1. A solid shape like this is a collection of flat surfaces enclosed together. If we unfold it, we can look at every face at once. Flattening the prism shows us the shapes that make up its structure. Because a rectangular prism has 6 faces, the resulting net contains exactly 6 rectangles. Representing a solid as a flat net lets us transition from trying to visualize a three-dimensional object in our heads to examining simple two-dimensional shapes laid out on a single plane. To find the actual surface area of a larger rectangular prism, we look at these dimensions, 4 by 3 by 2. Here is the flat layout of the new prism on a sandy grid. By separating the net into distinct pairs of faces, we can systematically measure the area. We calculate the area of the first unique face pair using the 4 and 3 dimensions. 4 times 3 gives us 12. The second unique face pair uses the 4 and 2 dimensions. 4 times 2 gives us an area of 8. And the final unique face pair uses the 3 and 2 dimensions. 3 times 2 gives us an area of 6. Measuring the total physical spread of this net across the shoreline grid defines its range. Every unique rectangular face we measured has an identical opposite partner from the original prism. Each face area appears twice in the final count. We begin building the total surface area sum by grouping the first 2 distinct pairs, 12 plus 8. Pause the video here. Remembering that every face has a partner, determine the total surface area of the entire net.
The net shows all faces. Find each area alone. Add them together.
To find the final surface area, we add the 3 unique face areas together and then double the sum. 2 times the quantity, 12 plus 8 plus 6, equals 52 square units. Breaking a 3-dimensional shape into individual 2-dimensional components turns a spatial puzzle into a series of simple multiplication facts. Finding the total surface area requires tracking each face pair systematically until the entire structure is accounted for. These flat mapping rules apply to any solid made of polygons, including this triangular prism. Unfolding the net reveals its individual surfaces. It contains 2 triangular faces and 3 rectangular faces. Why can a net show all 5 distinct faces in one flat drawing? The net unfolds the solid so the polygons lie perfectly flat without overlapping. That flat arrangement lets the total surface area be measured all at once. The physical action in the environment reveals the geometric relationship, while the notation on the stone records the result. Regardless of a solid space shape, unfolding it into a flat net provides a universal method to see, measure, and add total surface area.
Fold it back up. Surface area is covered. Unfold something today.